Hey, I'm Josh. We're going to be talking about electric power.
Hi, my name is Alicia and we're going to talk about electric power.
Hi, I'm Brian, and we're going to talk about electrical power.
Yeah. And I'm Dimitri, and we're going to be talking about electrical power. Things first. We're going to do a little demonstration on electric power. With this battery and an everyday device known as your cell phone. Everyone has one, right? Good.
I have
Okay.
one.
So, we have a 3.7 volt battery here. And we've determined that the resistance of this cell phone through strenuous mathematical equations is 3.9 times 10 to the 4th ohms. Let's see what happens when you combine volts with resistance. What would you get? What do you think you'll get?
A phone.
Well, we'll see. We get what we call electrical power. As you can see, the phone turns on. Now, electrical power can be found with many home items today, such as a camera. Yes. Yeah, see, that's electrical power. Even a calculator.
A calculator as well has electrical power.
Yes. And we have this iPod, which everyone has and loves to listen to music from.
Of course.
And this phone that also has electrical power. Now, we have Brian, who's going to give us a little bit of facts on electrical power.
Hey guys, I'm going to tell you some facts about electrical power. Electrical power is defined as the rate at which electrical energy is transferred by an electric current. The standard unit for power is a watt. Electrical power is characterized by a current or the flow of electrical charge and voltage. A given value of power can be produced by any combination of current or voltage values. If the current is direct, electrical charge progresses.
Electricity is a form of energy involving the flow of electrons. All matter is made up of atoms, and an atom has a center called the nucleus. The nucleus contains a positively charged particles called protons and uncharged particles called neutrons. The nucleus of the atom is surrounded by negatively charged particles called electrons. The negative charge of an electron is equal to the positive charge of the proton, and the number of electrons in an atom is usually equal to the number of protons. When the balancing force between the protons and electrons is offset by an outside force, an atom may gain or lose an electron. When the electrons are lost from an atom, the free movement of these electrons constitutes an electric current. Electricity is a basic part of nature and is one of our most widely used forms of energy.
Earlier, I told you that strenuous mathematical calculations were used to find that the resistance of this phone was 3.9 times 10 to the 4th ohms, right? Well, we use the formula R equals V over I, which will now be demonstrated by Felicia.
To find the resistance of the phone, you need to use the formula R equals V over I. The phone's voltage is 3.7 volts. The phone's current is 950 milliamps per hour. This could be converted to 9.5 times 10 to the negative 5 amps. Next, we plug in these numbers into the equation and we get 3.7 divided by 9.5 times 10 to the negative 5 amps equals to 3.9 times 10 to the 4 ohms, which is the resistance.
Now use it to find the power.
Alright. Next we find the power. And the formula for that is P equals VI. Since we already know what V and I equal, we just put it into the formula. 3.7 volts times 9.5 times 10 to the negative 5 milliamps equals 3.5 times 10 to the negative 4 watts. And that's your power.
As you can see, we demonstrated it mathematically and with this phone. So, we'll see you guys later, because I'm Dimitri and I'm cool.
And I'm Brian G. We'll see you guys later.
And I'm Alicia Paul. See you later.
And I'm Josh. See you next time.